So good afternoon, everyone. Thank you all for joining us at this event. So today we will discuss COVID and the power of data science using R. Before we start, I would like to introduce Parvez and I. I'm Phoebe, by the way, from Taylor Woods, and we will be hosting this event today. We are very pleased to invite our key speaker, Philippe from HSBC, who will be joining us on the virtual Zoom stage today. First of all, please let me give you a bit of background about Taylor Woods and of course our key speaker as well. Taylor Woods is the leading legal compliance risk and regulatory recruitment firm. We are one of the 5 brands under the SR Group, and we have 14 offices and over 250 consultants globally. Parvez and I work in the risk management and analytics space at Taylor Woods London. Our primary sector is banking and financial services industry. We cover both permanent and contract roles across market risk, credit risk, operational risk, and analytics area. Our key speaker today, Philippe, is a PhD holder, and he has held a number of high-profile roles within financial services and academia. Currently, he works at HSBC Poland, where he is the head of model risk management team and the head of diversity and inclusion. In addition to his role at HSBC, he is also the honorary consul for Belgium based in Krakow. Philippe has also recently published a book called The Big R Book, From Data Science to Learning Machines and Big Data. For those who are interested, I will post a link to the book at the end of the talk. Today, we are going to discover the power of data science and R programming with Philippe, and he will also show us how data scientists built a COVID-19 dashboard that allowed not only to simulate, visualize, and compare, but also to predict. And finally, we will have a 15 minutes Q&A session at the end. And if you have any questions during the talk, please wait till the end, and you can use the Q&A function at the bottom of the Zoom screen, and we will go through it together with Philippe at the end of the talk. Now, without further ado, let's welcome our key speaker, Philippe. Please, if you may.
Okay, Phoebe, thank you so much for this kind introduction. It's a pleasure to be here with you guys, and thank you so much for inviting me. So I want to bring you a little story to start with, a story about data and somehow how important data is for everyone in this world. You see, my story started when I was, this particular story started at my birthday this year. You see, my birthday is 21st of February. And you might probably remember that in Italy, we had a situation that we had a few COVID cases for a while. And that was number 3. And for weeks, there were just 3 COVID cases in Italy. And people were thinking, well, COVID, maybe it cannot transmit from person to person. Maybe it is only common in animals and it transfers just on people that somehow got in contact with contaminated food, for example. However, at my birthday, we suddenly had 20 cases. The next day we had 62. The next day we had 155. And at the birthday of my wife, the 24th of February, we had 225 cases. And then you see the whole world reacting to that. The World Health Organization was saying, well, we don't want to declare a pandemic because we don't want to create panic. We will keep it the way it is now. And most people were downplaying the problem. And none of the governments was doing anything. But you see, as a scientist, you know how a virus will spread. A virus will spread exponentially. You see, I am sick, and during the course of my sickness, I will infect 2 other people. But those 2 other people will infect 2 new people, each of them. So you see how it grows from 1 person to 2 people, to 4 people, to 8 people, and that goes really very fast. quick story to get up to speed about the exponential curve is the story of a person that did something really great for the Chinese emperor. And the Chinese emperor asked, well, what reward can I give you for that great service that you have done for me? And that person said, well, give me 1 grain of rice for each square on the board of the game chess. And you double it each day. You see, today you just give me 1 grain of rice. Tomorrow I come back, you give me 2. The day after, you give me 4, and then 8, and so on. But of course, there are 64 boxes on the chessboard. Of course, the emperor thought, well, really, a few grains of rice. Here you go, here is your grain of rice, and come back tomorrow. But by the end of the game, the emperor of China owed the debt of something that is in today's terms 700,000 times the total annual production of rice. So thinking about exponential growth, it is something that we easily underestimate. And it is really very tricky because our mind is set up to think linearly. Our mind is wired up in the savanna of Africa, where you have to shoot a rabbit, and the rabbit has a linear speed, your arrow has a linear speed, and you have to estimate where both can meet so that you have meat. Our brain is not good in understanding how exponential growth works, but exponential growth is dangerous. Exponential growth underlies everything from growth of viruses to fire to nuclear reactions, everything. So we know how dangerous this is, and I wanted to do something. I was talking to many people, and it appeared that there wasn't so much people interested to listen to what I had to say. So I went off and tried to find some data. My idea was, well, let's share some data. And so the data that I could find, here you see it, is from Johns Hopkins University, and they keep track of which date, which country, which province, longitude, latitude, number of confirmed cases, number of people dead in that place. And you see the numbers start to increase. You can see that. But of course, well, there are multiple countries. The time that the COVID stays with us is increasing, and you see that is a long list of data. That is absolutely not even nice to look at. In the end, we have around 90,000 records. That is the situation today. So I needed to come up with something more meaningful, with something that could help to convey the message about the dangers of that exponential growth. And hopefully governments would be wise and try to change something now when it was not too late. Of course, we know how things happened, but in the end, what I tried to do was build was building a dashboard. The buttons were kind of hidden under the buttons of Zoom. So here we are. Here is a dashboard that I was starting to build. The tool that I was using was the software R. And R has a very neat interface, which is called Shiny. Or if you want to build a Shiny dashboard, you can use the interface Shiny dashboard. And it's kind of intuitive to build up things. In the end, what you have to do is to build up a HTML5 page. People that know HTML understand that H4 will be a header of level 4, and that will create a header of selected country. And so there is a quite intuitive, simple set of functions available to build up a dashboard like this one. So my first attempt was, well, I know what I'm looking for. You see, let's maybe jump for a second to a simulation of how a virus development can look like. That simulation here shows in the blue line how the cumulative number of infected cases could look like. Because you see, okay, what it actually does is following some kind of scientific model. SIR model. At the beginning of the infection, everybody is susceptible to get the disease. Then some people get infected, that is the I, and then some people get removed from that population not to come back. So the idea is that people are removed from the population of susceptible because they have been sick and are resistant, or they have been sick and they didn't survive it. So that very simple model with a very simple logic behind that the number of people infected in the next day is actually dependent on the number of people before the number of people recovered is depends on the number of people that had the disease in the first place. And if you program that simple logic, you find something like that. You see, first it grows exponentially, but of course, there is not an infinite number of people in your country, so it cannot continue to grow exponentially. At some point, it has to slow down. So the shape of that curve is called a logistic curve. That's a very important one. And actually, if you test that, you could say, well, here we have a country of 10 million people, so why don't we just add 1, 2, 3 zeros and simulate for the whole world population how it could look like. So in the whole world, well, you see what it changes. It takes a little bit longer to really start doing something. We start on day 0 with 100 cases, and before you see something happening, it takes a while. That also indicates that probably this COVID was around for a while before it started to spread so fast. But anyhow, the point is that you can be looking at a massive amount of people that won't survive it. The number of the death toll can go into hundreds of millions of people. And then, of course, people are saying, well, there are only 200 cases infected in Italy. What are you panicking about? Okay, so I wanted to convey this message. My first attempt was to make a simple dashboard, just this page, with just showing the numbers. Making the numbers move intraday is already nice, or you kind of get some feeling. It's actually horrible. While we are speaking, you see how we can expect that more and more people get infected. Some people recover more, fine, but still the number of sick people goes up. And oh, it is another person that died. That's absolutely sad. That is something that already brings data a little bit to life. The next thing that I wanted to do is to remember this exponential growth, and at some point it starts to slow down. I try to find that slowing down point, or that inflection point as it is called. These indicators should be 1 at the inflection point. So the number of worldwide infections is slowing down. Number of deaths, not yet. Recovered, we have an issue. Okay, let's have a look at the data. And you can immediately see what the issue about recovered is. Well, first of all, not all countries report recoveries. That's another problem. But the second problem is there is a huge correction here in the number of sick people and recoveries. So that basically makes it impossible for that middle thing to work, but the number of cumulative number of infections, biggest number, seems to be stable. Of course, people might be more interested in their country. So for example, let's take the country from which this speech is organized, and Taylor Root's headquarters is in London, in UK. So here is a curve of UK. You see at this point, we have almost 2 million people infected. UK doesn't report on the number of recoveries. That's why they are 0. Other countries, let's say, for example, Poland, they do report on recoveries, and that's how it is looking in Poland at this point. This very simple thing already makes the data come to life. And the advantage of working with R and RStudio and Plotly library that sits behind the plots is that actually you really don't have to do too much effort to get a nice interface that looks good and that also brings the data to life, because now the user, well, you can really select the part of the things that is of interest for you. And you can see, well, let's try to find out what happened in the early days in Poland. They have that maximum here, so let's see what happened in that period. By zooming out the data, you really understand better what is exactly happening. So all such interaction is something that comes almost free. You don't have to do too much programming apart from the logic based on your data. But of course, the most interesting thing is, okay, what can we expect? Well, while this is good to give you some indication, it's actually still pretty hard to see if there is really a trend, or is it just some random variation. We come back to that one later. So knowing what type of model we are looking at, exponential, logistic, maybe linear at some time, we can try to fit a model. So for example, let's try to fit the number of confirmed cases. Now the problem is it's a very strange curve. You see that logistic shape here, but let's maybe just focus on what we have in early days. Let's just take the simulation up to, let's say, beginning of April, maybe a little bit further. You see when you're doing that, the data automatically adapts and we should be able to fit a logistic curve. In those days, it seems possible that the thing was under control in Poland. And yes, actually, the Polish government reacted quite soon. As soon as we had infections in the country, they had a lockdown in place. And that lockdown was very efficient, worked, and the number of cases started to increase. So if you increase the number of days to forecast, you see that the whole thing somehow is converging to a total number of infected people of 10,000, meaning that you could expect, based on the number of the death rate that you had in Poland, which is basically an indication of how many cases you pick up compared to the real cases. So that will bring the death number around 500. That would actually have been a great job. However, today, it's a very different story. So let's just look at what's happening in the latest months, and maybe let's make a plot from November. Of course, that doesn't work because the end date has to be later than the beginning date. It seems that again, we are able to fit a logistic curve. The number of dead people is now converging to 30,000, probably even more. So that is a very different story. And now you can actually calculate how much lives it has cost because the government wanted to open up early and create an environment that things were under control. They had some political agenda that was behind, but it's still something that, well, makes you think about it, isn't it? Another thing that I wanted to do is actually, that's the type of thing that this dashboard does well. There are more dashboards around that give you data and beautiful maps and stuff like that. But what this one helps you to get started is make your own models. So to make it completely open, what I also provide is a table of data. Here is a time series of the country that is selected. So again, if you prefer the UK, then you just select another country and automatically you have the UK data. You can download it as a CSV file, for example, make your own analysis. Interesting to see is also the daily variations. Of course, there is quite high volatility, so it is pretty hard to see what is exactly going on. So the number of confirmed cases. Well, it seems that in the UK, we had kind of a situation where we had a maximum around the beginning of November. It cooled down, but it seems to be moving upwards, which is a very bad situation if you think about Christmas and New Year around the corner. And something that I just recently started working on is a report. So let me quickly show you the test version that I have here. Is the same thing, but because the window is narrower, the interface looks a little bit different. You see, again, another advantage that you have of working with the Shiny library. So I told it creates HTML5, but under that HTML5 sits the CSS library Bootstrap. And Bootstrap is responsive design, which means that the dashboard, if you make it wide, it will look different than when you make it narrow. And so, okay, I can here show the PDF report that is still in very early stages, but just to show you that it is possible, with one click of the button, you should be able to generate a report for a specific country. And it is also kind of interactive. The selections that you have made here, the dates and the number of days to forecast, that will be automatically reflected in your report. And you can make it as beautiful and interesting as you want, of course. Just to show it is possible, that functionality is not really ready at this point. That is one thing. How is it evolving at this very point in one particular country. The other thing is, of course, hold governments more accountable for what they're doing, and let's say, well, let's compare countries. Of course, there is also the table, but again, that is not very useful. In that sense, it doesn't really come to life. The way to start is probably looking at things like this. How does it evolve in a certain country? Oh yes, we see where the correction that was in the world data is coming from the US, and that's probably a correction in the number of recoveries. So let's work with the number of confirmed. And then of course we see that the UK and all other European countries, they're kind of small compared to what is happening in India and US. Okay, so this is just a set of countries that I pre-selected here. You can go over and select your own in the long list of countries. For example, we want to add Sweden to the list because they had a very particular way of doing things. So now they are added. Sweden is in yellow, Poland in green, UK in brown. But again, that doesn't really work well because, you know, that is a big country, that is a small country. So let's do it differently. Let's calibrate for the number of population. And what it does now is dividing by the number of people in the country. Let's also not calibrate the x-axis. So basically now the x-axis starts in a point where the country has 5 or more infections. So let's not do that and just keep dates on the x-axis, because today that exact starting point is maybe not so important anymore. Let's just see what is happening at this very point in time. Let's zoom out just a little, and we already have a story to tell. You see really what is happening is as a percentage of the population. So 100 means 1%, 200 is 2%. So US already has infected 5% of its population. India was on a course to become world champion and pass by US, but that didn't happen. And then you here see a group of countries like the UK, Poland, and Sweden that seems to be on a very similar course, despite very similar approach of the governments actually. And then you have a bunch of countries here that seem to have the situation more under control, situations like Canada, Mexico, India. Or maybe it's a story of previous viruses that already created some resistance. We don't know very well what exactly set those countries apart from policy, but even within the groups that look similar, there is a wide variety in policy. And China, which definitely has policy in place. But still, looking at this plot, for example, so the upper curve in gray is the US. You see that there was a first wave and then it slows down. And then you have around the period that you had the Black Lives Matter protests, another wave, and then it slows down. And then you have the election fever and you have another wave of development. But the problem is that whenever you have a new wave, the previous wave will look pretty small. And so it is pretty hard to say, well, is it really another wave or is it just some random variations? So we need something else. I will skip the map and answer that question first. So I came up with this plot. These are the same countries minus Sweden because I didn't add it at this point. And this basically is a curve where you do not have time on the x-axis, but just the number of confirmed cases and the new cases per day. So looking at here, when we had 100 cases in your country, actually any country, we had like 10 new cases per day. And any country seemed to have moving along that line with more people infected and infecting every day more people until they had 10,000, and then they had like 100 new cases. Again, 10%, and that seems to be constant. It is only when countries reach an infection rate of about 10,000 that there is some variation here. And so it first of all seems that we're all at the same highway to our own doom. And it takes a while before governments actually can react. It's pretty hard to get people to react and people act safely when there are no infections in your country. Although in countries like New Zealand, for example, I think they did a really great job. So what you expect to see is that we're all on the same highway, and that 10% new infections is a constant that depends on the virus more than on the country. And at some point, it should fall off a cliff, and you should have that very nice straight move line downwards. That is what happens on a very closed population like the Diamond Princess. That is one of the boats. And when we add this one, we should be able to see that. Okay, it's a little bit convoluted by all the rest, but you see the Diamond Princess was on that same line. At 10% new infection, still it drops off a cliff. And that is the type of thing that we want to see in all the other countries. And now, of course, one detail maybe is that we take a rolling mean over 7 days. Otherwise, there is too much variations and you basically don't see too much anymore. So you need to roll moving average of 7 days. So, okay, zooming in again, and now we can really see what happened in the US. Indeed, they basically did nothing till they had like 500,000 cases infected. Then their policy started to work and it started to go down. Then you have the BLM movement and it starts to go down. And then you have about 5 million people. And then it starts to go all the way up again. And at this point, it doesn't look particularly good for them. It seems that they are almost parallel with the highway, which means 10% new infections every day. So this tool has proven to be quite predictive. You can see very early that the trend is setting in. And if then the efforts of the governments are sustained, then that will make a difference. This tool is able to see easier a trend or earlier, like more or less a week earlier than all the other things that I've shown. I did also say that I skipped the map. So let's have a look at the map now. And for example, the number of dead people. That is, of course, one way to visualize data and also to tell stories about data. So let's maybe look at the number of confirmed. Of course, the scaling we would want to adapt, but I won't do that for a second. And just play all the way back to the beginning and click on that play button here. And then as we speak, you see that thing will be slowly moving, and day by day, you see what is happening. Or you see the infections growing and growing in that central province in China. Some satellite provinces, the bulbs are getting bigger and bigger. Oh, and now in Europe, we have everywhere some infections. We're only the beginning of February, but we have Italy, France, Spain, Britain, Belgium, Germany. We have Sweden, we have the US, we have Canada. We have some infections in Africa. We have India already. And we see that it's very much a Chinese story. But oh, now today, we are 3 March, we see Italy growing, and really putting itself on the map. We have here, I believe that's one of the other provinces here. UK is growing very fast. France, Germany, Spain is catching up now. And you see the story developing before your eyes. You see how history played out. I think it's really a beautiful thing to be able to do that with so little amount of code. Okay, so fast forward to today. As I said, I have to rescale the bubbles to make them look reasonable. And of course, you can have all the type of interaction that you want. You like other colors. You like that the radius of the circle would be proportional to the number of infections or the surface of the bubble and all these kind of things. So a lot of interaction, a lot of things to play with, and that really helps people to understand what is going on. Okay, let me stop the discussion here and hand back over to you in case there are any questions.
Brilliant. Thank you so much, Philippe. That was really interesting. Thank you. Guys, if you've got any questions, sorry, it's Parvez here. If you have any questions, if you want to message on the group, and we'll start answering those questions. But whilst people are coming up with questions, Philippe, would you mind just telling us a bit about the book that you've written? What inspired you to write the book, and how will it help us and data scientists who managed to actually acquire the book?
Oh, well, thank you so much, Parvas. That's a question very close to my heart. Let me first put in the chat box some links. So people, if you move the cursor on the screen and you move it, then you will see appear in the bottom or on the top of your screen some menu buttons. And one of those will be chat. And the next one, next to that, you will see Q&A. Q&A is to answer the questions. So if you have a question, it's better to put it there. And in the chat box, you will find some links that I wanted to share. So about the book. Yes, I think there are many books about data science already, and they are probably particularly good in what they exactly want to do. For example, data manipulation or big data or code optimization or machine learning models. But what I try to do is to put everything together actually. And while we are waiting for questions, let me maybe try to share that. Okay, so, right, let me show this. This is my homepage. On that homepage, I have a link to the pages of the book. And here you have the table of contents. And basically what it tries to do is follow the story of data. It tries to follow, let's say, from data gathering to databases, what is happening to data, how can you get data out of databases, how can you manipulate data in such a way that it becomes usable for your model, then how do you make the model, how do you validate the model, how do you make sure it is not too overfitted, and then we try to understand more about how companies work. For example, how do you calculate the value of a share, maybe in a simple way, but at least it gives you an idea about what makes your manager tick. It also has a chapter about multi-criteria decision analytics, and then we move on to reporting, convincing people that what you have done with your data is meaningful and useful. Then we have a section about big data and code optimization. And in total, the book is around, it was 1,000 pages, so we printed it pretty small. To have it under 1,000 pages, that seems to be more attractive for people to buy and read. But anyhow, there are 800 parts of code in the book. There are about 150 illustrations and so many other things. So it has been a big part of my life the last years to build it up. It has been built on experience that I have gathered for the last 30 years and documents that I started to write in courses that I started to teach at universities for the last 8 years, more or less. Okay,
Hi, Philippe. I think we have the first questions from Alex. He asks, are all these implemented in R, and are the code and data available on GitHub?
Not yet, but that is something that I would definitely consider to do. Till now, it has been a one-person effort, but honestly, it would be better if more people would want to help and we could indeed create one GitHub. So if that person would be interested in doing something with the code that I have and maybe work together, then maybe the best way to do is to contact me via email or via Phoebe. And yeah, let's talk about it and see what happens. I have no a priori reason why I want to keep the code secret, for example.
No problem. Alex, I will share the contact with you.
Okay, thank you so much.
Philippe, also, if anyone wanted to go ahead and purchase the book that you've written, how would we go about doing that? What's the easiest way, if you don't mind me asking? Sorry, I don't mean to just promote your book only, but I think it will help budding data scientists out there if they were to pick up the book. Also, one question from me: why R? Why not another programming language? Can I ask?
Oh, very good question. I like both of those questions. So first of all, if you go to the homepage of the book on my website, and I put it again in the chat box, there you will find links to all the sellers of the book. You see on that, maybe I can just share it again for to show you how it works. But here, one of the parts is get your copy, and then you just click on the links that suit you best. If you're in France, you might want to take Amazon France. If you want to use Barnes and Nobles. So the book is available on all those companies' websites. And this link, we can test it right away if it still works. It should bring you directly to the book that I'm talking about. And indeed it does. It has some rating here even. And from that website, you can buy it. That's probably the best way to go. The second question, why R? And honestly, that is because I was starting to work with R. I was amazed about what it could do and how R is actually pretty good in making very complex things simple. Unfortunately, R also has a nasty habit of making simple things a little bit too complex. But anyhow, it is not supposed to use as just a simple calculator. It is not a simple Excel sheet. And indeed, R has a certain learning curve. But the thing is, it is free software. And so everybody can use it. And that is also why it is so much available at universities, and all people doing statistics and developing new methods and ways of working. Well, they will try those things in R. And before, for example, you want to optimize a neural network. That is actually a lot of work. When I was at university, we would code in C, and it would take days or weeks to have something that would be working, and then you try some different data and things stop working again. Well, that work has been done over the years, and people have contributed a library neural net into the community of R, and everybody can use it. So if you want to fit a neural network, it's one line to load the library, and it is one line to fit your neural network. And there it is. And then magically R understands how to use that fit of the neural network, and you can plot it, you can ask summaries, and that works very intuitively in a very nice way. But talking through all those things, you might be saying, well, yes, why not Python? And honestly, there is no good reason why it would be R and not Python. The only reason there is that R was more familiar for me. I don't know Python that well, but both are very valuable, and both do more or less the same thing. At least for statistics, Python does a lot more outside of the statistics world. It encourages younger people or even kids to code. It is good for coding games and things like that. R probably wouldn't, well, it probably isn't the strongest choice available for such kind of things. So Python is more universal language. And when it comes to statistics, it is definitely at par with R. So there is no particular reason to go for one or the other. The reason why I now support more R than Python is because Python is getting the overhand. Python is maybe a little bit faster in acquiring people that know Python. And that's why I want to support R as much as possible, because I believe there is value in capitalism. I believe there is value in competition. And if Python would be the only language that people were using, then it would be just very much the same as one political party that is the only choice in a country. It is not an optimal thing. So we need competition for Python. And we have good competition there with R. And the way I'm looking even at bigger private companies is that people that are doing meaningful things with data, statistics, analytics, modeling, and so on, that those people should be able to use the language that they like at that moment in their life, that they feel familiar with, or that might be just best suited for the type of task that they have at hand at this point. You might like to code in Python and it works fine for most of the things, but you might need that specific R library. And honestly, both of those things you can use as a framework. And that is also the story of the whole book, where you go from data, connecting to the data, making the models, validating the models, reporting about it, and that whole stream can be automated completely, or at least to a large extent. And there is no particular reason in paying very much to specific companies that solve a part of that puzzle, because the whole puzzle, from data collection over data manipulation to data visualization, all that is freely available in softwares like R. I honestly believe that that would be, if more companies would embrace that, people would work more meaningful with data, we would solve problems that we're not solving right now, and it would be an edge for smaller companies also, because that kind of make things more democratic. I hope that is an answer to your question, Parv.
Absolutely, that's been brilliant. I think you answered another question. I think Brendan had a question in regards to Python, but I think you've just answered his question too, to be honest. So thank you very, very much for that. Just wondering, in terms of, we're hoping that we can host you again in next quarter, just to have a follow-up discussion to see what the numbers are looking like in regards to COVID. But and also, if you have any future plans on writing further books, we'd be keen to hear about those. But I think from our side, it's been phenomenal, sir, having you on. It's been absolute pleasure. Look forward to doing it again in the future. And just thanks to the guys at Taylor Root for organising this for us as well. So they've been brilliant. To everybody that's joined in, thank you so much. Please do feel free to link in with Philippe directly. He is very, very welcoming. He is very free with his time as well. And yeah, if you've got any further questions in regards to what myself and Phoebe do and how we can support you, either as a candidate or a client, or to host a similar event, please do get in touch. Thank you.
Thank you all. It was fantastic to be with you guys. Have a nice evening.